Hello everyone, Mrs. Germany here. We're going to look at writing and solving an equation from a real world situation. So we have our 5-step process, but we always want to begin by reading our question. So our problem says, in a 3-year period, a city's population decreased by 7,525 to about 581,600. What was the city's population at the beginning of the 3-year period? Now, we're going to use our 5-step strategy. So step 1 is to identify. We want to find the numbers, operational words, and determine what is needed. Now, I like to highlight this, okay? So the first thing it said was numbers. Now, it does say 3-year period, but even though there's a 3, because it's hyphenated with a word, probably not. But this number here, the 7,525, that's going to be a number I bet's important, as well as the 581,600. Okay, so there's 2 numbers. How about operational words? Well, when I think about operational words, that word right there, decreased, I remember that one. And then what is needed? What am I being asked to find? I want the city's population at the beginning of the 3-year period. That's what I'm being asked to actually find. So now I have done my identifying, okay? Be careful, you don't want to highlight everything, just what you really, really need. Now, step 2 then is to strategize. And this is defining the variable is really what's going on here. Okay, so I always like to use x just because x makes life easy. So I'm going to use the variable x. And ask myself, what is it that this is representing? Well, you can usually find it in the question part. I want to know the city's population at the beginning of the 3-year period. Okay, so I want to know cities pop before. All right, before where we're at now. So this is what I want. I want the city's population before. Write that out so you can see it. I know for these early ones it may seem silly, but trust me, they're going to get harder. All right, next we need to set up. We actually need to write our equation. Okay, so it tells us that the population, the city's population, decreased by the 725 or 7525. So if this was the original population, then my equation would be x minus the 7525. All right, because decreased is subtraction. And that it's now, that's going to be my equal sign, 581,600. All right, so that's my equation. I just set that up. So my population decreased by 7,525 and is now 581,600. Okay, so I did setup. Now solve. Well, if I look at this, this is just a one-step equation. So I am going to use inverse operation, and what I see is subtraction. So inverse operation would be addition. So I'm going to add 7,525, and I'm going to do this on both sides, 7,525. All right, I add that on both sides. Again, these cancel out. All right, we like to be able to see that. So those are going to cancel each other out. Those are gone, which leaves me with my x on the left, and that's by itself. That's exactly what I want. So my x equals, and then when I do this addition, what I'm going to find is I'm going to find that I have 589,125. That would be the original population. All right, now the check step is literally just to say, does this make sense? Okay, if the population decreased, does it make sense that in the 3-year period before it had to be more than this? Yeah. So is 589,125 bigger than 581,600? Yes, it is. So the answer makes sense and we're good to go.